Welcome to this brand new section where we're going to be talking about cryptography, and this particular lesson is going to be one of the longer lessons in the entire course, so strap in your seat belts. So cryptography is basically a secure communication technique that would allow only the sender and the receiver of a message to view it. That's the whole point of cryptography. There's a few terminologies that you need to be aware of. We have something known as a plain text. This simply refers to an unencrypted message. Now, a message that has been encrypted is what we call a cipher text. Cipher itself is the process or the algorithm that is used to encrypt and decrypt a message. And then we've got something known as cryptanalysis. This is the art of cracking cryptographic systems. So keep these four terminologies in mind. Now, there's three main types of cryptographic algorithms. We have hashing algorithms, and then we have the symmetric encryption cipher, and then we have the asymmetric encryption cipher. Let's take a look at them one by one. The hashing algorithms, this is the simplest type of cryptographic operation and will produce a fixed length string from an input plain text that can be of any length. Now, this output, the output of a hashing algorithm, can either be referred to as a checksum, the actual message, a digest, or a hash. It's very often referred to as either a hash or checksum. Those are the two most common names used to refer to the output of a hashing algorithm. Now, there is something you should be aware of known as a hashing collision. This happens when two different plain texts end up producing the exact same hash value. It's not very common, but it does occur, so keep that in mind. Now, hashing algorithms, they used to prove or verify the integrity of a file or password. Let's take a look at an example in here. Stage one, you've got Alice. Now, by the way, let me quickly mention this. Whenever you read any kind of book on cryptography or encryption, there are three main characters that are universally used. You've got Alice. Alice is typically the sender of the message. Bob would be the receiver of the message. And then you have Mallory, who would be like the black hat who tries to intercept and modify the communication between Alice and Bob. So let's take a look at this example to explain hashing. Here, stage one, Alice will publish a file and the reference hash value. So the file right now that she's sending to Bob is hello world. That hello world, the text hello world, will be hashed and will produce the hash value. Now, stage two, Bob is going to download the file and will also record the reference hash value. So Bob has the hash value that he has gotten from Alice. However, he wants to make sure that the hash value is actually correct and that the message he got from Alice has not been tampered with. So what Bob will do is that he'll compute a hash and will compare it to the reference value. So Bob is going to take the text hello world, get the hash value, and if the file has not been tampered with, it should produce the exact same hash value with that of Alice. Now you have stage four, where Mallory might try to inject a malicious download but will not be able to change the reference hash value. So even though Mallory might have been able to inject some sort of malicious download to the file, because the hash value will no longer be the same, Bob knows that, okay, this particular file has been tampered with. Now, hashing algorithms. You've got the secure hash algorithm, SHA. This is considered to be the strongest algorithm, with the most popular being the SHA-256, which would produce a 256-bit digest. The next kind of hashing algorithm is the message direct algorithm, number 5, MD5. This is weaker than the SHA because it produces only 128-bit digest. Here's an example from Microsoft about the hashing. So the file here is simply photo.jpg, and right there you can see the hash value BAA30028. It's very long. This is just an example of what a hash value would look like. Let's talk about the particular kinds of attacks that can be launched against hashing algorithms. By far the most popular is the birthday attack, where a brute force attack is aimed at exploiting collisions in the hash function. Remember that a hash collision occurs when two different plain texts end up producing the exact same hash value. And it's used very, very commonly in forging digital signatures. Now, how will this actually occur? In stage one, the attacker will create two different documents. One will be malicious, while one will be benign. It will just be an ordinary document. But the key here is that both of these documents should produce the exact same hash value. So what the attacker will now do is that he will send the benign document for signing by the target. He's going to send the ordinary document to the victim to sign it. Now, once the victim has signed that document, the attacker will then simply remove the signature from that document and then add it to the malicious document, forging the target's signature. That's how this would work. Now, the birthday attack works because of the birthday paradox. You may have heard of this before, that there is a 50% chance that if you have a group of 23 people exactly, the two of them will share the exact same birthday. So the point here is that even though hashing collisions are not common, it still occurs when you've got two different plain text producing the exact same hash value. So what will happen here is that the attacker will simply create multiple benign and malicious documents to exploit this paradox. He will produce as many documents as needed in order to get two documents that have the exact same hash value. So encryption algorithms must demonstrate collision avoidance, meaning that once a particular kind of document is encrypted and another is encrypted, that algorithm should be able to demonstrate that, hey, my type of algorithm will not produce hashing collisions. It's known as collision avoidance. So the birthday paradox has also been used to exploit collisions in the MD5 function to create fake digital signatures. There is also another kind of attack known as the downgrade attack. Before two devices communicate securely, both sides must first decide on the best possible encryption algorithm to use. Now, in a downgrade attack, imagine if the attacker was able to sit in between these two devices and then influence that conversation by simply downgrading the encryption algorithm that can be broken easily. So instead of using a very, very strong encryption algorithm, the attacker is able to convince both parties to use a much weaker encryption algorithm. That's what's known as the downgrade attack. Thank you for watching. I will see you in the next class.